All right, this is the Math Models Unit 1, Lesson 9 video over direct variation and proportional change. There's not a whole lot to say about this lesson. The idea of proportional change is this idea that some relationships exist in which, if I were to say, the school, Premier High School, has for every four, it's not very good, for every four female students, there are 6 male students. So, therefore, if I told you that I have in the school 100 female students, how many male students would I have? And so because we're saying that this is a proportional relationship, we can figure out how many male students there are. And that number would be 150. And so the idea here is that the relationship between those two values is the same between this ratio and this ratio here. And so what we end up with is this idea called direct variation. And the direct variation formula is basically that I want to know this value k. Okay, and the relationship for k is that there's a couple different ways to say it. Y equals kx, or another way of looking at it would be that k equals y divided by x. So in our example, we could say that the male students are the y and the female students are the the x. And if I wanted to find k, then I would say that the k value is 6 over 4, also known as 1.5. So in other words, the number of female students times 1.5 will always give me the number of male students. Another way of looking at it is that, again, if I put 6 for y equals k times 4, then, all right. So this is this k value, and the k value is basically telling you that that's the number you can multiply by to get from one part of the relationship to the other. So in this lesson, they're going to basically be giving you values that are in a proportional relationship and having you find k. K, which is what we call the constant of proportionality. Constant of proportionality. Mouthful. All right, the constant of proportionality. So it's very, very straightforward. They're going to give you something like this. K times 25 equals 115. You need to solve for k. What does k equal? So this is a basic, very basic algebra problem to say that I divide by 25 on both sides of the equation, and then k equals whatever 115 divided by 25 is. So I can go over to my calculator and do 115. 115 divided by 25. 4.6, also known as 23 over 5. So 4.6 is my answer right there. So all I've done here is just solve this little equation, 115 equals k times 25, and I solved it for k. That's all you got to do. That's all you got to do on number 2. Solve for k. Solve for k. Solve for k all the way down till you get to number 6. And in number 6, they mix it up a little bit. Now we're given this formula here, y equals kx, we're given the value for k, we're given the value for x, and we're supposed to find the value of y. So you need to take this formula and plug in the values for k, which is 2, and the value for x, which is -3. Multiply those numbers, and you'll get what y equals. That's all you do for number 6, number 7, number 8, number 9, and all you're doing here is solving for either x or y. So if they give you values for k and y, then you're going to take this formula, y equals kx, you're going to plug in for y, which is -3, equals 2, which is k, times x. Solve for x. Well, if I want to solve for x, then I'm going to do divided by 2, and x equals -3/2. And we have that as an answer choice right there. So again, you're just solving these little basic equations to find that missing value. Number 10, plug in k and y, solve for x. Then in number 11, through the end, we change into some proportionality word problems. And so we're going to take a little bit of a different approach here. And I'm actually going to work out a couple of their examples for you guys. So they say here, Alex gets 2 base hits for every 9 times she is at bat. If Alex has 210 base hits, how many times was she at bat? So we know that Alex had 2 hits for every 9 at-bats. And we know that Alex has 210 hits total. How many at-bats? So I've just shown you how to set up this problem. You're going to write a proportion. A proportion is always going to line up each relationship with the things in the same part of the fraction. So the hits are always going to be on the top, at-bats on bottom, or vice versa. In fact, in their way of working it out, they put the at-bats on top and the hits on bottom. Doesn't really matter. And this is an example of a situation where we are going to do cross multiplication. So I put my x there because that's the thing we don't know. When we do cross multiplication, when we have a proportion, there is a property of proportions that says I can multiply things that are across from each other diagonally, and they will be equal if I multiply those things. So 2 times x will equal 9 times 210. 2 times x, we just write 2x. 9 times 210 is, 1,890. 90. Then I solve for x just like I've been doing in this section so far. And I get x equals 1,890 divided by 2. And I get 945. So that's how many at-bats we would have if we got 210 hits. Let's go over here. And that was our answer right there, 945. All right. So that's more or less how you're going to work out these problems. So I'm going to kind of get you started on a few of these. For instance, the weight on number 11, the weight of a snake is directly proportional to its length. If a 4-foot snake weighs 2.5 pounds, notice I went ahead and wrote that as a fraction. How much would a 5-foot snake weigh? I wrote that there because that is where feet are located in the top. All I have to do, 4 times x, 5 times 2.5, solve that equation just like I did, just like I did here. The cost of carpeting a floor varies directly with the size of the floor. Again, if a 400-foot squared floor cost $1,800, what is the cost of 625 square feet? So you're going to cross multiply, and then you're going to solve. Again, same method as those other problems. Number 13, almost exactly the same. Number 14, once in the first second of travel, they went 16 meters. How long, how many seconds would it take to travel 1,101 meters? There it is, set up. I'll let you do the rest of these. This is pretty straightforward. So, yeah, that's pretty much it. I've gotten you started on a lot of these. It's a lot of just basic algebraic solving equations. And that's pretty much it for this lesson.